We've covered some of this in class, but I want to introduce the Poisson distribution here with this video. The Poisson distribution is this discrete random variable that has a very specific probability mass function. So generally, we look at variables where it's going to be a rate of successes over a given time period. So here I'm looking at the number of successes over a week. Maybe I'm thinking about successes. It could be whatever I'm looking for. So maybe I'm thinking about, okay, on average, there are, 8 car crashes on a specific road. So it's a success in the sense that that's what I'm looking for the probability of, like what's the probability I see 8 or 10 or 5 crashes this week, right? But it's not a success necessarily in terms of good for society. However, if I'm considering I have to staff kind of EMTs and responding officers, maybe I'm interested in the probability of seeing a higher number of car crashes because I'm concerned I won't have enough resources. So here within our probability mass function, lambda is just going to be that average rate we typically see. And this is going to be something that's given to us, right? Or we're pulling from historical data. X is just, okay, if I'm interested in finding the probability that I actually see 10 accidents this week, right? So the number of successes I'm interested in finding the probability of, that's my X value. And then E is just this natural number. It's kind of like the number, pi. I believe it's 2.71828. So this is usually there's a button built into our calculator that stores this value, or kind of as a rough estimate, 2.71828 would kind of give that to us. Already have talked about the factorial in class, but if I wanted something like 5 factorial, that's just start at 5 and multiply all the way down to 1. Right? This is a little faint. So here, if the average rate is 8, the probability that I see 10, right, I can find that by using this probability mass function. My lambda value is 8, my X value is 10, e to the negative lambda, so e to the negative 8 divided by 10 factorial, right? So we generally have a factorial button on our calculator. We can plug this in, we've got the E button on our calculator, or we could 10 times 9 times 8 times 7, we could type that into our calculator as well. If we do that, we're going to get about 0.099, I believe. So the probability that we see 10 car accidents based off the average rate of 8 is about 0.099, right? Or 9.9% chance. Now, kind of intuitively, let's say I was more interested in, okay, what's the probability I see 16 car accidents this week? Well, my lambda hasn't changed. It's still 8. The X value, or the number of successes I'm now interested in finding the probability of, though, is 16. Plug in e to the negative lambda. My X factorial is now 16 factorial. And I get something like 0.0045, I believe. So notice, as we move towards a number of successes that are further from that average, well, if on average we see 8, it's a little bit less likely we would see 10, and even less likely that we're going to see 16 this week. Right? As we move away from that average, notice that probability of seeing a higher number of successes further from that average value of 8, that probability has declined. This is just kind of an introductory example into using the Poisson distribution. We'll cover more examples in class, but this should get us going.